And so we have two phenomena occurring in the body overall because of the hypertrophic fat cell. One, the body's becoming ever more inflamed. And two, the body's becoming filled with circulating fat that it doesn't know what to do with. Those free fatty acids that it can't burn because insulin's too high. And if insulin's high, the body doesn't burn fat. It can't really store in the fat cells anymore because the fat cells are already too full. And so then you have this more ectopic fat deposition that we've both alluded to already, where you start storing fat in tissues that are poorly designed for fat storage, creating things like fatty liver disease, and that could progress into full-on steatohepatitis and cirrhosis and liver failure and myriad other problems. But it all comes back to this series of events, a fat cell that has become overfull, or in other words, hypertrophic. And then to bring that back to the female phenotype, it starts to happen with the loss of estrogens. You can't do that. And I would submit you wouldn't want to. So what you would want to do, rather than just correcting the fat cell's ability to respond to insulin, what you'd want to do is allow it to respond well to insulin. And while you cannot control the effect of the fat cell, you can control the insulin. So don't look at correcting the fat cell. You can't. It's out of your hands. You can correct the insulin. And that comes back to all the strategies we've talked about before, and I know you've talked about in other podcasts. So we can't blame the fat cell for just doing its job. And so we shouldn't try to correct it. What we should try to correct is the stimulus that continues to aggravate the fat cell, because that we can correct. Glucagon is insulin's opposite, the yang to the yin, and that is reflected in multiple cellular processes. The most obvious is their battling effect with glucose. Whereas insulin wants to lower glucose at any moment of time, glucagon wants to increase it. But the differences continue. And it's in a way thematically represented by the fact that insulin wants to store energy in the body, glucagon wants to burn it. Ketogenesis is the process of burning a lot of fat and turning it into ketones. Well, it's no surprise that insulin inhibits that, because insulin doesn't like burning things. It just wants to store them. And it's no surprise to learn that glucagon activates that. It stimulates it. So it's the balance of these two hormones that, in a way, have a profound whole body effect on nutrient metabolism. And now you mentioned protein. It's interesting to note what protein does. I'm an enormous advocate of dietary protein. I think most people don't get enough of it, and they're accidentally avoiding the best sources of it, or deliberately avoiding the best sources of protein. But protein will have a variable effect on insulin and glucagon. If someone has very, very high glucose levels, then protein can have, in fact, an not inconsequential effect on increasing insulin. So if you have protein in the midst of high glucose, it can be pretty significantly insulinogenic. And then this overall ratio of insulin to glucagon gets quite skewed. However, if the protein is being consumed with fat, as it is in nature, there is literally no exception to this. In nature, all protein comes with fat. Always. In our hubris and our fear of fat, we've pulled the two apart, thinking we know better than nature does. So I'll just talk about protein alone. But if the protein is coming into the body in the absence of a high glucose level in the blood, then the insulin effect is essentially non-existent. It may be there, but it's very, very modest. And this has actually played out in multiple human studies. I very much resent people saying that protein has a significant insulin effect, because I can disprove that so readily through so many human studies. It doesn't in the absence of glucose or in a normal glucose level, but it does increase glucagon. And so overall, the net metabolic effect of the protein is metabolically favorable in that it is going to help the body use energy rather than just store it. Not to mention the fact that protein has a very good effect on satiety, and protein increases metabolic rate because of the act of digesting and absorbing it more than the other nutrients do. So for all of those reasons and more, I'm an advocate of protein, but that even is reflected in these hormones like insulin and glucagon, and others like ghrelin that would stimulate hunger that goes down, and other hormones like GLP-1. But suffice it to say, I'm an advocate of protein. I know you are too. And the overall the net effect on the metabolic state of the body is reflected in a way with the changes in insulin to glucagon in their ratio.